Okay, let's look at what job a resistor carries out within an electronic circuit. So in your circuit simulator, press V and draw a voltage source, then W for a wire, R to draw a resistor, and W again to draw the final wire to complete the circuit. And you'll see as soon as you join that, we get a current flow, these yellow dots, around the circuit in a clockwise direction. You've still got this cross pointer on the screen, so hit escape to get you back to pointer mode, away from draw mode. So you've got a voltage source here, you've got a resistor which by default is 1000 ohms. So 1K means 1000. And we've got a current flow in a clockwise direction. If we reduce the size of this resistor, we should get a larger current flow. So instead of 1000, we can put in 100. And we see right away that the current flow has become much greater, because the flow of current is the voltage divided by the resistance. And if we reduce down the resistance, we're going to get an increased flow. So putting it back the way it was, put this back to 1000, and it automatically renames it as 1K because that's the usual naming system used. If we change it to 10K, we should see a very slow current flow indeed. Let's go back to 100 and we'll check out the calculation. So if we set it back to 100 ohms, we've got a flow, a fast flow in a clockwise direction. If we double click the voltage source, we can see that it's, by default, it's 5 volts. So we've got 5 volts pushing the flow of electrical current clockwise, and we've got 100 ohms resisting it. So the flow is going to be the voltage divided by the resistance. So the voltage is 5 volts and the resistance here is 100. So the flow should be 0.05, and the unit for flow is the amp, so 0.05 amps. Now we can check that by coming to our circuit here. I'll just press the stop button to, oh, the stop button isn't going to work here because we still have this window open, so we can just cancel that. I'm going to press the stop button. I'm going to disconnect this wire. I'm going to delete it completely. So we've broken the circuit, and instead I'm going to put in, if you come up to the draw here, outputs and labels, we should be able to add an ammeter. Ammeter kind of being short for amp meter, a meter that measures amps flow rate. So if we click on that and drag it across and press start, we see that this instrument that's going to measure the flow rate is reading 50 milliamps, which is the same as this value, 0.05 amps, the milli being thousandths. So 50 thousandths of an amp is this value. And if we change our resistor back to what it was originally, 1000 ohms, we should now have 5 divided by 1000. If we want to change it here, 5 divided by 1000, which is going to be 0.05. So the voltage here pushing the electrical current around is 5. The resistance here is 1000, and in order to do the calculation we can't put it here as 1, obviously it needs to go in as 1000. 5 divided by 1000, 0.005, and that tallies with the instrument here that's reading 5 milliamps.